Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Loka Seva Gurukulam. Science in that sources of energy part 4. We have already seen some of the topics in this. We have seen about the good source of energy, the characteristics of the good source we have already studied. Also we have seen about fossil fuels, namely coal, petroleum and natural gas. They are called as fossil fuels, which gives a very good source of energy in the present day scenario. Of course, it has got its own limitations. Also, we have studied about thermal power plant and hydro power plant, where hydroelectricity, the water from the moving water, the electricity is produced. That is what is called as hydro power plant. Also, you have seen about solar energy, energy got from sun, and energy from the sea in the form of tidal energy, ocean energy, etc. Also, we have seen about geothermal energy, the energy got from the earth with high temperature, that the temperature is made use of to heat the water to get steam, and the steam is made use of. And now let us see the home assignment. A question was, name 2 sources of energy sources that you would consider to be renewable. Give reasons for your choices. And energy derived from biomass is a renewable source of energy because the waste products are continuously used. So, the waste product also used for plants and agriculture purpose, and plants and trees are grown at reasonable intervals. So, therefore, it is called as a renewable source of energy. And also we have seen the flowing water, wind, sun, ocean, etc. a renewable source of energy because that can be harnessed into energy so long as the solar system exists. Something like 5 billion years. As long as the sun is there, solar energy will be there, and naturally all other connected to it like water, wind, etc., ocean, etc. will be there. So that is a renewable source of energy. That's what you have seen. And next question is, compare and contrast biomass and hydroelectricity as source of energy. Biomass is a renewable, clean source of energy. Why it is called clean source? There is no smoke produced, is it not? And it is easily transferable also. But the rate of availability is moderate because it depends on the cow dung and wastes and all. It is not continuously got. Then coming to hydroelectricity, it is also renewable and it is also a clean source because the water that is coming from the river is controlled by dams, by which a large amount of electricity can be produced. But it is in limited sites. You cannot have dam at all places, and also it causes environmental damage also. So much of plants, animals will be disturbed by this. So anyway, it is one of the good source Limitations of extracting energy from wind, waves, tides. Limitations you must tell. It needs a large open space to couple a number of windmills. As you know, the windmill produces a very limited source of energy. It is not sufficient to run any machines, etc. So, you must have many number of windmills. So, to have number of windmills, it needs a large open space. Secondly, can be topped only during specific periods when the wind speed is above 15 kilometers. So, below 15 kilometers it is not useful. That is why it is one of the disadvantages. And wear and tear of windmills parts is quite high due to storms or due to the birds. Big birds will come and attack windmills unknowingly. It all give trouble. But repair of these parts is a very costly affair. And coming to wave energy is viable proposition only when and where the waves are very strong. If the waves are not strong, the amount of energy getting from waves is not sufficient. And that's why it's difficult to time and location is difficult. It got what is called as constraints. Difficulties will be there. And also tidal energy, it has limitations on the height of the tides. Ocean tides will not be same all the days. On full moon day, new moon day, etc., it will be very high tide. Other days it will be little neap tides. So, depends on the tides. And also, to get tidal energy, the locations also very important. Because we have to construct a small dam type wherein the water is to be controlled. And huge amount of silt will be gets deposited. Because sea water contains some salts and these salts will come in a hindrance. It is a hindrance for the production of electricity. That is what is called as silt. So, these silts deposited on the bases of the dams will also hamper the production of electricity. That is why these are some disadvantages, limitations of tidal energy. Coming to today's topic, we have nuclear energy. It is created by a process called nuclear fission, and one more is nuclear fusion. So, first of all, you must know what is nucleus. Every atom has got a center called as nucleus. In that nucleus, there will be protons and neutrons. Protons are positively charged, neutrons have no charge, and around this there will be electrons. Electrons will be going around the nucleus with fixed elliptical orbits. So, they will be going around. So, there the protons and neutrons together called as nucleons are bound by a force, and that is what is called as nuclear force. And nucleus of heavy atom is to be taken. Heavy atom means uranium, plutonium, thorium, etc. They are radioactive also. Are taken, they are bombarded with low energy neutrons. So, they are hit. To give a very simple example, all of you know carom game, is it not? In carom, what do you do? For to start with, all the pawns should be kept in a vertical column, right? In the middle of the board, right? You take what is called as a striker. I think you understand what I am telling. So, when hit by a striker, you must hit it such a way that the same direction where the pawns are kept, and there should be a proper speed also. The speed is more, it may avoid or it may not touch the tower of the pawns. So it should be a moderate speed. Here also neutrons are made to bombard the heavy atoms. What happens then? It split up into lighter nuclei. For example, uranium, if it is hit by a neutron, it splits up into barium and krypton with an evolution of enormous amount of energy. Okay. So also in carom you can see when hit by a striker, what happens? The tower of the pawns will fall down and one or two pawns will be scattered, and that is what the first step. Here also they are split up into lighter nuclei. I said about barium and krypton. When this is done, tremendous amount of energy is released, and that energy, here the mass of the original nucleus, namely uranium, is just a little more than the sum of the masses of barium and krypton. So here when uranium nucleus is hit by a neutron, here when you take isotopes 92 mass number, 235 isotope is to be taken. When it is hit by a neutron, you get barium and krypton, and huge amount of energy is released. Here the mass of this barium and krypton will be less than this, and that is how this mass is converted into energy, and that is based on the Einstein's equation, and that is what is called E is equal to delta mc square, where E is called energy and delta m is the mass of the product, and C the velocity of light. What is the velocity of light? 3 into 10 to the power of 8 meter per second, the velocity of light. Actually it is measured by the unit called electron volt. In nuclear physics we are going to study in detail in second PU class. It is called electron volt, also called EV, and the higher unit is called mega electron volt. 1 mega electron volt is equal to 10 to the power of 6 electron volt. So that is very famous equation called as Einstein's equation, and this device which converts nuclear energy into electric energy is called as nuclear reactor. Here of course one important point you must note, the nuclear fuel, namely uranium 235, that is isotope. What do you mean isotopes? Isotopes are the atoms of elements which have the same atomic number but different mass numbers. For example, uranium has two isotopes, one is 238, another is 235. The availability of this is very less, but that only is taken. That is why the process is very costly. To separate these isotopes is a very difficult process. So that is called nuclear fuel. It is taken a part of self-sustaining fission chain reaction. There will be what is called a chain reaction. In one of the reactions, they are in multiples. in the chain reaction, there will be multiples of say 1 neutron, and second one is 3 to the power of 1, 3 neutrons, then 9, 27, then 81, etc., etc. And these again continuously bombard the uranium nucleus. That is what is called as chain reaction, and that produces enormous amount of energy. But it will be controlled. That is the difference. And one of the application of this nuclear reaction is in nuclear bombs. You might have heard about Hiroshima and Nagasaki, the two worst hit during Second World War. They are the islands in Japan. They are hit by these nuclear bombs, because of course nobody, even Albert Einstein was shocked. He gave this formula for the good purpose. Unfortunately, the evil-minded worked it and made use that is why it is called science without humanity is useless and dangerous. Politics without principles, science without humanity, education without character are not only useless but also dangerous. That is one example. In Second World War, lakhs and lakhs of people died. Even now also the effect of the bomb is there, because that is the worst hit. On that day only the Second World War ended, 1945. And so then the scientist went on thinking of the good purpose, and our Dr. J.H. Baba, Homi Jangir Baba, H.J. Baba, that is why you can find in Bombay there is one atomic research center called Bhabha Atomic Research Center, BARC. And there what they do is the nuclear reaction is controlled, and what that energy made use of, that energy is used to produce steam, and then it is used to rotate the turbines and hence producing electricity. So nuclear reactor, of course you are going to study in detail in next second PU class. So one of the very good sources, but in India we have got only 3% of the energy resources of producing electricity is made use of by nuclear reactors, because it is a very, very costly affair and there are so many disadvantages which we will study later. So this is what is called Einstein's equation. This equation was made use of. Here the nuclear fission, the difference in the mass delta M, difference in the reactants and product, that mass is converted into energy. Nuclear and product nuclei gets converted into energy, which I was just now telling you, and that is what is called as nuclear energy. This is one of the process of manufacturing nuclear energy. And in India we have got nuclear power reactors at Tarapur, Maharashtra, Rana Pratap Sagar, Rajasthan, Kalpakam in Tamil Nadu, and we are very proud it is in Kaiga. Those boys and girls from North Kannada, Uttara Kannada, what you call, they know it very well. There is a place called Kaiga. Our campus also is there, very near to it, Kaiga, 20 kilometers. And there you have nuclear power reactors. And there are some others also, smaller units. And they also will supplement some of the materials for the nuclear reactions. And what are the hazards? The first hazard is that nuclear power generation is the storage of the nuclear fuel, namely uranium, thorium, etc. And disposal of spent or used fuel that causes lot of dangers. You might have heard about the worst danger that happened in Chernobyl. Chernobyl is a place in Russia where there was a great havoc. Lakhs of people died and millions lost their lives and homes, etc. because of the evil effect of this disposal. Because they have radiations. The substance that comes out will be having radiations, and these radiations are very dangerous for the plants, animals, birds and so on. That's why they have to be taken to a very remote places, hilly stations, and they make very big cement tanks. In that, these disposed atoms will put there. They are taking extra care. In India, nothing danger has happened so far. Anyway, it is environmental contamination will be there. Very difficult to dispose the waste materials. Risk of accidental leakage. Sometimes because you have to add what are called as control rods and fuels and so on. In this process, there will be possibility of accidental leakage, which is very dangerous because they are all radioactive substances. What do you mean radiation? Suppose you sit in front of the oven in your house, you feel the heat. Even if you stand outside in the hot sun, you feel the heat. That is a form of heat radiation, conduction, convection, radiation. Without heating the medium, heat is transferred, one of the radiations. The high cost of installation of a nuclear power plant, I was just telling you about that. Even separation of the isotope 238 from 235 is a very, very costly affair. Transport is another costly affair. Construction, so many things are involved. Anyway, it is a very good source of energy because it is the only one type of energy which is not directly linked to sun. All other sources of energy are linked to sun one way or other. But here there is no question of sun, introduction of sun anywhere. And one more thing is limited availability of uranium. So we cannot produce in large scale, but there are some countries which produce about 30% of energy sufficient for substitute for electrical energy. And availability less. In India also it is very less. That's why you cannot produce more nuclear energy. And first it was used for the destructive purposes, preparing nuclear bomb, also called as atom bomb. Okay. And then one more method of producing this nuclear energy is called nuclear fusion. As the name itself says, fusion. You heard about sound fusion. 2-3 type of instruments together, if they sing, it is called fusion. Here, the nuclear energy can also be got by nuclear fusion, that is joining of lighter nuclei to make a heavier nucleus. For example, hydrogen plus hydrogen gives helium plus neutron. Helium, so conversion of hydrogen into helium is a nuclear fusion process. Here also enormous amount of energy is produced, and we can see this in the case of sun and stars. This enormous amount of energy is got by the fusion reaction. Okay, here this is called isotope of hydrogen. What is isotope? Same atomic number, different mass number. See, hydrogen has got 3 isotopes. Mass number 1, and mass number 2 called as deuterium, and mass number 3 tritium. Here atomic number is same 1, mass number is 1, 2, 3. So such atoms of elements are supposed to have isotopes. Iso means same, tope means place, same place. What is same place? In the periodic table, all these hydrogen isotopes have the same place. That is why it's the word isotopes. Similarly, you have isobars, isotherms and so on. So this is isotope, and here deuterium is taken, mass number 2. Deuterium is taken, so it produces helium, it fuses into helium. For that also lot of temperature is needed, but anyway there will be release of enormous amount of energy. This energy is more than the thermonuclear fission. This is called thermonuclear fusion, and that is fission. So it is more than that fission. So in the stars and sun, of course sun also is a star. Sun is our dearest and nearest. That's why we have separated sun, S-U-N. We have nuclear fusion reaction. That is why sun is there from 5 billion years, and it will continue to 5 billion years as sun only. It is 5 followed by 9 zeros. So it is still giving energy, even though we are at a sufficient distance from the sun. We are not feeling so much, but if we go nearer and nearer, we feel the hotness of the sun, millions of degrees Celsius. So the stars and sun, they have got continuous nuclear fusion reaction there. There you have hydrogen being converted into helium, and hydrogen bomb is on the results of that fusion reaction. It is prepared in the laboratories by the thermonuclear fusion reaction, taking light nucleus to fuse into heavy nucleus. But of course many nations have produced hydrogen bombs. 3 hydrogen bomb is sufficient to eliminate the whole world. That's why all nations who have prepared it kept it safe, because if once it is released, means they know very well many of the nations will collapse. That's why now God has incarnated as avatar to protect the world from this nuclear holocaust, and this is one of the dangers of that. Here this is about nuclear fusion. Now let us discuss about the environmental consequences, and that is because of the fuels that we are using. Exploiting any source of energy disturbs the environment. So in the olden days there were no nuclear energy, there were no the geothermal, this and that, tidal energy and so on, and that's why the environment was pure, calm and quiet. But now of course it is the need of the hour, because population is exploding and there are so many factors for that. So that disturbs the environment means what? It pollutes. For example, there will be air pollution, there will be noise pollution and so on. Pollution of the soil also. So burning of fossil fuels like for example, if you burn the coal or petroleum, for example, most of you know how the car and bike etc., when they move, they produce smoke and they produce what is called as air pollution. An assembly of device will cause some environmental damages. For example, solar cell, we discussed in the last class. Solar cell as it is is not a dangerous one. But when you assemble it in thousands, in many number of the solar cells joined together, will cause some environmental changes, damages. And coming to non-renewable sources of energy, the source of energy that will get depleted someday, fossil fuels like coal, petroleum, natural gas, etc. Now it is feared that in a span of about 25 years, the whole of the energy sources, namely fossil fuels, will come to a grand halt. And then what is the solution? You must think of bicycles, tangas, etc., etc. Bullock carts. You have to go back to the ancient, because now the consumption of these fossil fuels is so much alarming, so much very heavy. So they get depleted, means they get exhausted, and they are said to be non-renewable source of energy. And coming to renewable, the energy sources that can be regenerated are called renewable source of energy. For example, wind, flowing water, tides, ocean waves, solar energy, continuously is coming. Even though you use it for many days together, it is being used. So they are called as renewable source of energy. So anyway, energy is something very important for our life. From morning till night, we use the energy in different forms. And for our life also, existence also, energy is needed. So let us see some home assignments on this. What are the uses of nuclear energy? Just now we discussed that it can be used for production of electricity. That is one of the most important uses of nuclear energy. And what are the environmental consequences of the increasing demand for energy? What steps do you suggest to reduce the energy consumption? Third question, give the names of 2 energy sources that you would consider to be exhaustible. Give reasons for your choice. So these are the home assignments. Prepare well and answer these questions. Thank you.